past few days, we've been talking about the different types of slope. So we first started describing what slope would look like. If a line was increasing from left to right, we would describe that slope as being positive. If a slope was decreasing from left to right, we would describe that slope as being negative. If a slope went straight across horizontally like this, we said the slope was 0. And when the line went up and down, we described its slope as being undefined. Now remember, the slope is trying to describe the steepness. So this is telling me it has a positive steepness. This one's telling me it's negative. This one's telling me it has 0 steepness, and this is undefined. We can't describe how steep a line that goes up and down is. When we want to try to find the slope of a line and actually figure out how steep it is by giving it a numeric value, we use the ratio for slope as rise over run, whereas rise is representing the vertical change, or it's basically telling me as I move from one point to the next, how many spaces we move up or down. If we're moving upward, we would use a positive value, and if we're moving downward, we would use a negative value. Run is describing the number of spaces we move from one point to the next, left or right. If we're moving left, just like our coordinate plane, we would describe that value as being negative, and if we're moving to the right to get from one point to the next, we would describe that as a positive value. When we compare those two numbers, that's what creates our slope, and that's what gives us our steepness. So we're going to look at a few examples of how we can use rise over run given a graph to describe the slope of a line. So when we want to find the slope of a line, we want to look again for that rise over run. And again, in order to get rise over run, we need to have 2 points on our line. So in the first couple examples, I've identified 2 points that we're going to use. Now, when we want to find the slope, we start with 1 point. So I'm going to start with this point down at the bottom. Now, I count my rise, the number of spaces I move from that point up to my next point. So my rise for this one would be a rise of 2. I count up 1, 2 spaces. And then I don't move left or right at all. So that means in this case, this had no run. So when we have a fraction with 0 in our denominator, that number is undefined. And again, as we mentioned before with our 4 types of slope, when a line is vertical going up and down like that, it has an undefined slope. So even when we try to use rise over run, if we don't move left or right at all to get from one point to another, we end up with a 0 in our run space of our fraction. That tells me I'm going to have an undefined slope. All right. Now in this example, here are my 2 points. Now to do my slope, we're going to go from the bottom point to the top point. So again, first I'm going to start by counting my rise. And I want to know how many spaces does it take for me to go from this bottom point up to the same level as my second point. So when I'm looking at this, it's 1, 2, 3, 4, 5 spaces to get up there. So that means when I'm talking to my slope, since I moved up 5, my rise would be positive 5. Now, once I reach the same height, now I'm going to run. So I'm going to count how many spaces I would have to move, in this case, to the right to get to that point. And as I look here, there's 1, 2, 3 spaces there. So my run would be 3. So my slope would be 5/3. Now, in slope, improper fractions are okay. It's okay if your bigger number is on top. The only thing you would want to make sure that you would do is reduce your fraction if you can. But in this case, there is no reducing needed. So my slope in this case would be 5/3, and I'm going to leave my answer just like that. And it should make sense that my answer is positive because this graph went up from right to left. Okay, let's look at one more example where we have the 2 points drawn on our graph. And in this case, we want to go from this point to that point. Now, if I start with this point, I'm not going to rise. I'm actually going to have to go down to get to that second point. So when I'm moving downward for my slope, I'm going to actually use a negative value for my rise. So for this one, I'm going 1, 2, 3, 4 spaces down. So I'm going to describe that as a -4 in my rise part of my formula. And then to go over to that second point, 1, 2, 3, 4, because I'm moving to the right, that's going to give me a +4 for my run. When I look at a fraction again, I want to make sure I can reduce it. So -4 divided by 4 is simply just -1. So we can describe the slope of this line as -1. And it should make sense that we got a negative value because my line was decreasing again as I moved from left to right. Now you'll notice in my next 3 graphs, I don't have any points labeled. So what we want to do is we want to try to find 2 points that we can use to find our rise and our run. So what I do is I look at my line and I want to find where my line crosses through the corner of a square on my coordinate plane. So I can see there's a good spot right there, and as I trace the line, I can find another point right there. If I use those 2 points now, I can find my rise and my run. Now I know my slope should be negative because my line is moving down from left to right. So either my rise or my run has to be a negative value. If I start from this point, to get over to that one, I'm going to have to move down to get to the same level. And in this case, I would be moving down 2 spaces. And then to get over there, I have to run 1 space again to the right. And -2 divided by 1 is simply just -2. Okay? Now, you can pick your points as close together or as far apart as you like. I try to find the 2 closest together. That way I don't have to do too much in terms of reducing my fraction. Okay? So same thing in number 5. I should be predicting that I'm going to get a negative slope because my line is decreasing as I move from left to right. I'm going to try to find 2 good points to use. I see one right there. And as I move, I can see a second point right there. Okay, so I'm going to find 2 points where my line hit the corner of the square. And let's say I chose to start from this point and I wanted to move towards that one. It doesn't matter which way you go, you just have to make sure you're getting to this, you're showing the motion how you move from one point to the other. So if I started with this point, now I would have to go up to the same height as my other point. I would need to rise 2 spaces. But now my run would actually go to the left. I would have to move left towards that second point. So I'm going to use a negative number when I count it. So I went left 5 spaces, so I'm going to put a negative there. And if you don't like how that fraction looks with a negative at the bottom, a positive divided by a negative is a negative number. So we can move that negative up to the numerator and say that our slope was -2/5. All right, and then in my last example here where I had a graph given, but again, no points, I can choose any points I want. Any of the points in here are landing on the line. And when I go to count this, remember, if we think back to our 4 types of slope, we should be thinking to ourselves, the slope is 0 because it's a horizontal line. But if I want to show that by using rise over run, to get from this point to that point, I'm actually not rising at all. I'm staying on the same level. So if I'm using the rise over run formula, my numerator would be 0. And my run would be however many spaces. In this case, I picked 6. And you should remember that 0 divided by anything is 0. So just as we predicted by knowing our 4 types of slope, a horizontal line where the numerator has no run, our slope is 0. And back up here, when we had a vertical line, we should remember that's undefined. Notice we had a rise, but this time no run. Okay? Now the last thing I asked you to do with terms of slope was to draw the graph yourself. So I gave you 2 points, and then you had to create your picture, and you had some coordinate planes that you could print out if you wanted to. But what we want to do is we want to graph these points first. So I'm going to go to +9, and then -6. So there's my point, +9, -6. And then I wanted to go to -7, and then +6. So the first thing I asked you to do was to plot your 2 points, and then I asked you after you graph them to then find me the slope. So once you graph them, you can again use rise over run. So let's say we started with this point down here. We're at 9, -6. We would want to rise all the way up to the same height as our other point, and then we would have to move towards the left to get there. Now this was down at -6, so if I move up 6 spaces, that's going to take me here, and then the next one was at a height of 6. So for this one, my rise was actually 12. And then here I started at 9, and I moved backwards all the way to get to this point. So from the starting to the axis there, that would be 9 units. And then from here to here, I went back 7 units. So from this point all the way there, I went left 16. So my slope, if I'm looking at rise over run, I would take my rise of 12, divide it by -16 for my run. Should make sense. It's a negative slope. My points are moving down from left to right. And then I would reduce my fraction. 12 and 16 are both divisible by 4. So 12 divided by 4 would be 3. 16 divided by 4 would be 4. And a positive divided by a negative would be a negative. So my slope would be -3/4. Okay, let's look at one last example where again I'm going to plot my 2 points. So 8, 2, and then 3, 1. This time, that's a very shallow line there. This time, as I move from one point to the next, I'm going to go up to the same height. So I'm going up 1. And then if this is 3 and that's 8, my run was 5. So my slope for this one, my rise of 1 and my run of 5. And again, if you have your coordinate planes where you could actually count the squares, you would see that. All right. So that's what I want you to be working with as you're doing your slope problems. If you have any questions, feel free to email me.